Hello, Math 3 students. We're going to go over this Quizizz review that's posted under here. Click on Unit 1 Review. The quizzes that we started in class today is asynchronous now. So you can click on this and it should take you right to the link and you can put in your name. So I'm going to go ahead and copy that link on there and I'm going to do a split screen. So I'll see you back after I pause the video and get that split screen going. All right, we're ready to start. I'm going to name myself I Win. So I challenge you to do better than me. I think you can. Here we go. Question number 1. Solve for x. 4 times 2 to the 2x power minus 3 equals 60. You can lose logs or graph intersections. So let me first say that if you have Desmos, which you all do, any equation can be solved with a graph intersection. You can see what I did. I typed the left side of the equation here. On the right side, I would do y equals 60. And I would move that down. Click on the intersection, and I get 1.989. So I can get my answer by just doing that, 1.989. But you really need to know how to do this using a logarithm for some of these problems because some of them aren't going to be, some of them are going to be exact in terms of log. So what you're going to do is you're going to take your minus 3 and you're going to add it to both sides. So you'll say 63 on the right side, and you get 4 times 2 to the 2x power equals 63. Then we want to divide both sides by 4. So if I divide the 63 by 4, I will get, I think 15.75. Let's double check that in Desmos. 63. 15.75. And then you have 2 to the 2x power equals 15.75. Once you get it to the point where you have a number raised to a variable or a combination of numbers and variables equals another number, then you write it as a log. So you do log with a base 2, then you do 15.75, and then you set it equal to your exponent. That's going to go all the way out here at the end of your equation. So we say equals 2x. Now we can get this number from your calculator. So you can say log base 2 of 15.75 by writing the following things. LOG, hold down the shift and the minus key. That's right next to the 0 and hold the shift down. And you can put the 2. Put the right arrow in there and close up a 15.75 in the parentheses. You end up getting 3.97727. So if you take that number and divide by 2, you'll have solved for x. So that number divided by 2 is going to be 3.97727 divided by 2 will give you that same answer we got. So let's do that. 3.9772799 divided by 2. And it's going to be 1.9888. So we're going to round to 1.989. 1.989. Nice. Let's do the next one. Oh, I'm playing against myself. Hopefully more of you will join. Let's do another one. Let's do logs with this one too. Solve 13 to the 2x equals 84. 13 to the 2x equals 84. This one doesn't have anything out front, so it's simply going to be, since I don't have to add a number or divide, I'm going to write log base 13 of 84 equals 2 times x. Then I can take that number and divide by 2. So whatever this is, use your calculator for that. Divide that by 2 and you'll get x. So let's do that in the calculator. Log shift minus 13, right arrow, parentheses 84, and then just hit divided by 2. You end up getting 0.86372. So we'll say 0.8637 since it says 4 decimal places. Yes. All right, next question. Keep up. Pause it if you can't and retry some of the questions. Solve for x. All right, we'll do this one as a graph. You don't have to do every one as a log. So we would do 5 raised to the, now use parentheses when you have multiple terms in the exponent. So we would do parentheses 2x minus 6. Then you can close up the parentheses, hit the right arrow, it'll bring it down, and then you have your expression. Now down here, we'll say y equals 2137. I'm going to press the home screen. As you can see, y equals 2137 is way higher, so we got to drag this down. It does help to zoom out. And then maybe once you get it centered, you can zoom back in. And let's click on that. We're on to 3 decimal places, 5.382. There it is. So sometimes you might want to use your graph. All right, the next question. A population has 25,000. If it grows by 7.4% per year, about how many years will it take to reach 60,000? Well, to set this up, you have an exponential growth problem where A is your starting amount, lowercase a. It grows because that's 1 plus r, and then this is going to be your r, but as a decimal, it's 0.074. So remember, not 5. Remember, we take that decimal and move it 2 places to the left to convert it from a percent to a decimal. So this is going to end up being 25,000, parentheses 1 plus 0.074 raised to the t power. And it says, how many years is it going to take to reach 60,000? Well, that's your final amount, right? So we can set that equal to 60,000. So let's solve this one by hand since the last one we did with a graph. We want to first divide by this 25,000 to reduce this a little bit. So 60,000 divided by 25,000, that's going to be 2.4. So the base is going to become 1.074. Because you know that's just 1 plus 0.074. So that's 1.074 to the t power equals 2.4. Now I can do a log. So we do log base 1.074 of 2.4 equals t. And I don't have anything else but t in my exponent, so I don't have to divide or add or subtract at the end. I literally just got to go on the calculator and type this out. So let's get that done. That's going to be log shift minus 1.074, right arrow, 2.4. And it looks like your answer is 12.26. Now, one thing you can do, if you're not sure if your answer is correct and you don't want to graph it, or if you're not really getting good graphs, you can take your equation to start with, 25,000, parentheses, 1 plus 0.074, and you can raise it to your answer. You see how when I put that number in place of the exponent, you get about 60,000, which is what our goal is. So 12.26 will round to 12.3. Next question. A population of bacteria grows exponentially according to the function p of t equals p of 0 times 1.38 to the t power, where t is measured in hours. If the initial population size was 3,000 cells, that is a typo, that should be a comma. Approximately how long will it take the population to exceed 18,000 cells? This is very much like the last one, right? This is going to be your PO. That's your initial. So that's going to be 3,000. And we want to know when it's going to be 18,000. So we want to know the final amount. So there really is nothing different from the setup for this problem. You would still divide by the 3,000 and then do the log. So it's going to be divided by 3,000. You could also get an intersection with the graph. And that's 1.38 to the t power. And 18 divided by 3 is 6, so 18,000 divided by 3,000 is going to be 6 as well. Then you can do a log base 1.38 of 6 to get your t, to get your exponent. And it says round it to 2 decimal places. So let's see what that puts us. Log shift minus 1.38, right arrow, 6. And I'm getting 5.563. So 2 decimal places would be 5.56. So it's going to take 5.56 hours in this case, since that's what your t increment is, to get that population up to 18,000 cells. All right, next question, number 6. Here we go. We're going to almost be halfway through. I'm excited. Oh, I'm in the lead. Look at that. Look at all these people I'm beating. All right, next question. You have a car currently worth $18,000 that is depreciating at a rate of 13% per year. So depreciating means decay. That's decay. So that's going to go down. So that's going to be 1 minus the rate. So we want to know, what's the car going to be worth in 7 years? So we'll say 18,000. Let me back up and say capital A equals A parentheses 1 minus the rate to the t power. So 18,000 times 1 minus 0.13, because our percent as a decimal is 0.13, and our t is going to be 7. That's a t. So our rate is 0.13. That's 18,000 times that number to the 7th power. You can double check that in a calculator. It should be 0.87. So when you compute that in Desmos or your preferred calculator of choice, you get $6,790.58. So 6,791 would be your answer. Right, cars depreciate fast. Okay, so my advice is to never get a new car, because it doesn't really have the same worth. Unless you have the money to spend, I always get used. Okay, the next question. A ring you purchased for $2,000 is appreciating. Appreciating is growth. So this is the problem just the opposite way, right? It's going to be 1 plus r. And so we'll have A equals a 1 plus r to the t power. We have our initial amount. That's going to be your little a. And 1 plus your rate. Remember, your rate as a decimal, 2.5%, y'all, is 0.025. We got to move that over 2 spaces. And we want to know what's it going to be after 20 years. That's t. So raise it to the 20th power. So 2,000, 1.025 raised to the 20th power. All right, let's compute that, see what we get. 2,000, parentheses 1.025, close up, raised to the 20th power. 3277.23. There you go. All right, number 8. You invest $800 into an account that accrues 5% interest compounded quarterly. Which equation could this be modeled by? Well, what is quarterly? You say A equals P, 1 plus R over N to the NT power. N is the number of times it's compounded. Quarterly means it's going to be compounded 4 times a year, 4 quarters in 1 year, 4 quarters in $1. So N is going to be 4. Your P is going to be your initial amount, and your rate is still going to be 5%, which is 0.05. So we have $800, parentheses 1 plus 0.05 quarterly is over 4, but we also put the 4t in the parentheses. So let's figure out what that number is. 1 plus 0.05 divided by 4. 1 plus 0.05. 1 plus 0.05 divided by 4. You get 1.0125. So 800, 1.0125 to the 4t power. Well, which one is that going to be? 800 1.05, 800 1.05, 800 1.0125 to the x, or 800 1.0125 to the 4x. And that x would be our t in this case. So x equals t. It looks like it's going to be this one right there. Well, let's pick that. Heck yes, we got it. All right, another problem. The value of a computer can be modeled by v of t equals 925 times 0.51 to the t power, where t is the number of years since the computer was purchased. Which function best represents the value of the computer in months? So remember that to convert between a year and a month, we have to think about really two formulas, okay? We got our initial amount, 1 plus the rate, to the t power, where this is going to be years. So if I have my 0.51, this is actually 0.51, it's less than 1, so it's going to be minus because I guess it's losing value. So that number is 0.51 to the t power, and our initial amount is 925. But if I want to know what that is in months, I have to convert this to 1 over 12. So that's the same thing as saying 1 over 12 times the months. And we're going to figure out what 0.51 to the 1 over 12 is. So 0.51 to the 1 over 12 will get put into your calculator. And you're going to get 0.945433197848, so on and so on. So that's going to be 925. And then your parentheses, this will all get replaced by 0.945 to the m power. So now we have it in terms of months. And it's going to be this one, because it's 0.945. That's the m one there. So raise that that whole base to the 1 divided by 12. All right, next question. Faith opened up a savings account with the 7.2% annual interest rate. Which choice best represents her monthly interest rate? Well, we have a similar situation going on like before. We want to make our monthly interest rate from our yearly interest rate. But in this problem, we're not given the whole equation. We don't know what it starts with. We do know that it is a savings account, which means that it's going to be growth, which means that's going to be 1 plus r. So I do know it's going to be 1 plus 0.072. We don't know what the amount of years is, but that doesn't matter. Really what we're going to focus on is we're going to figure out converting this to months. So we're going to say 1.072 to the 1/12 times the month. Now we can take that 1.0172 to the 1/12 and we can just figure out what that number is. Remember, just like in the last problem. So let's do that. 1.072 raised to the 1 divided by 12. And you get 1.00581. So we're going to rewrite that as your starting amount times 1.00581, et cetera, to the m power. Well, here's the deal, guys. None of that's going to be your answer. But remember that 1.00581, that's growth. That is 1 plus your rate. So if you take away the 1 from there, you get 0.00581 as your rate as a decimal. So if you want your rate as a percentage, what do we got to do? We got to bring it over a couple spots. So it's going to be 0.581, which is your rate as a percent. So your monthly rate is 0.581%. Very small number. Number 11, here we go. What's the inverse of 4 to the x power? Inverses of exponentials are logs. So you don't really need to solve anything. Here's what you got to recognize. F of x equals 4 to the x power is an exponential function. Let me hit the home button. There we go. Where it's growing. Let me hit the home again. It's growing, right? It starts off flat, grows. The inverse of those is always going to be a log. So let's say g of x equals log. And then you do what's the base? Well, it's the same base. Got to have the same base. So you put the x in the log, and notice that they're mirror images over the line y equals x. They are reflections over that line. So it's as simple as that. You don't have to do any solving. You just got to recognize the same base as the log as the exponential, and that's going to be your answer. And one more question. How to convert between exponential and logarithm. These are some of the basic ones we did early on. So to get from an exponential to logarithm, you got to remember that, well, let me just use some letters. You start with the base. You raise it to the power. The exponent's going to be out here. And you set it equal to what's in the log. So let's work the other way. Your base of your exponent should be the base of your log. So that 3 should be down there. Let's cross these out. The number or value or variable in the log is what the exponential equation equals. So this number here, or value or variable, is the same as that, which means this 1 over 81 needs to be the number in there. And this is hidden, but it should say negative 4 over there. Your exponent is always what a logarithm equals. So that gets pulled out to the end there. So it's going to be log base 3 of 1 over 81 equals negative 4. Well, guys, I did really well on this. I'm going to give myself a pat on the back. Now you can too, and take as many opportunities to go through this as you'd like to. I want you to understand it. So watch the video, then do it on your own, and then watch the video again, do it on your own until you get it down. Have a great day, guys. Thank you.